In this video, we're going to solve rational equations. These rational equations, you'll notice, are slightly different than what we've been looking at because there's an equal sign with a fraction on either side of that. So these rational equations are not going to be very difficult in the sense that all we're really going to do is look at DESMOS to solve them. So where do solutions occur on DESMOS? They occur on the x-axis. So make sure you're looking at the x-axis for these solutions. The only tricky part is finding the domain restrictions. So like before, domain restrictions always come from the denominator. So for instance, we take the bottom and we'd say x does not equal 0 because we take the factors in the bottom and set them not equal to 0. If it's the same, we don't need to write it twice. We just can say x does not equal 0 once. So there's our domain restriction for number 1. 4 over x equals x squared plus 3 over x. The most simple way we're going to do this is by looking at DESMOS. So feel free to look at DESMOS. I'm going to just pull up a picture that I took from when I typed it in. So there's our equation, 4 over x equals x squared plus 3 over x. So this does not look like a rational function. Rational functions would normally do something like this and this. But instead we have two vertical lines. That's because we're typing in an equation. Normally DESMOS gives you a dot for the x-intercept, but whenever you have an x on both sides, DESMOS will not actually give you that dot. So we just have to draw it ourselves. There's a dot right there, there's a dot right there. So our solutions would be where we're touching the x-axis, which in this case would be -1 and 1. So what we would then do is just simply list our solutions as x equals -1, 1. You could solve this algebraically, but it's a lot more complicated, and all we're going to focus on is looking at a graph. So moving on to number 2, we have -2 over x plus 2 equals x plus 1. We only have one denominator. It's this x, so we just say x does not equal 0 for our domain restrictions. And then we would type this into DESMOS, which you can do. I'm going to pull up a picture. When you type this into DESMOS, you get -2 over x plus 2 equals x plus 1 and nothing on your graph. So when you see nothing on your graph, you know that there's no solutions necessarily because you're not touching the x-axis at all. This is a little bit tricky because we are typing in something that's not actually a graph. Like I mentioned before, a rational function should do something like this, which that also doesn't touch the x-axis. So there would be no solutions for that either. But because we can clearly see nothing touching the x-axis, this does not have any solutions here. But let's look at why that is. I'm going to do a little trick. I'm just going to change the equal sign. As long as my second side's in parentheses, I can change the equal sign to a minus. And now you can see two pieces of a graph that don't actually touch the x-axis. So this is not an exact picture of the function that we're looking at. We're actually looking at an equation, so not even a function. But it doesn't touch the x-axis at all, so that means that our solutions have to be imaginary. You can essentially just write imaginary solutions for now. That's totally acceptable, but I will go ahead and list those imaginary solutions for your ability to check if you'd like to do this the long way. The imaginary solutions here are x equals 1 plus or minus I square root of 7 over 2. So there are two imaginary solutions. They always come in conjugate pairs, but you could just say no solutions for that one, or no real solutions more specifically. I'll write that out. Then we'll move on to number 3. So number 3 says 4 over x plus 4 minus 1 equals x plus 6. Once again, we only have one denominator, x plus 4. So take x plus 4, set it not equal to 0 for our domain restriction, and we get that x is not allowed to be -4. So we list that as our domain restriction, and then we move on with finding our solution. So type that into DESMOS. Make sure you zoom properly when you do so. And you should get a graph that looks like this. We have a solution touching at -3 and another solution touching at -8. You can see them right here. So our solutions would just be x equals -3 and -8. So the DESMOS graph just tells us the exact answer just from looking right at the x-axis. Two more, and these two get a little bit more complicated, but only complicated in the sense that the graph, I think, doesn't necessarily look very good when you look at it in the normal way that we've been looking at it. So I'm going to show you two versions of the graph once again. So for number 4, we have a big long x squared plus 6x plus 8 over x squared minus 6x plus 8 equals 5. So we have to look at our denominator in order to find our domain restrictions. So factor x squared minus 6x plus 8. My x puzzle is 8 on the top, negative 6 on the bottom. So we have a negative 4 and a negative 2. Multiply to make 8 and add to make negative 6. So my factors are x minus 4, x minus 2. And then I can say x does not equal 4 and x does not equal 2 are my domain restrictions. So take those factors, set them not equal to 0, and then solve, and you'll get those two numbers right there. So we list those out. If we were to find a solution such as 2 or 4, they would not count because they are domain restrictions. If you can't plug it in for x, you can't get it out as a solution. So keep that in mind. That's essentially what domain restrictions are saying. So now we look at the graph here. And this graph's not too bad. You can see it, but I'm not a big fan of this graph when you just type in exactly what the paper says. It doesn't tell you the numbers by clicking on the gray dots, but you can assume that they are at 1 and 8. If you zoomed appropriately, you could probably see better marks than what I have on my graph here. But I want to look at a different graph to actually see these solutions. This graph, in my opinion, much more accurately shows what we would see for a function like this. And now you can see the solutions are at 1 and 8 confirmed. All I did was I changed the equal sign into a minus. Once again, this is a tricky thing to do because it's not just as simple as turning the equal sign into a minus always. You have to use parentheses. So I wouldn't recommend that you try it like this. As long as you get an answer like you did with the first graph, keep it that way. But you can see more clearly that this is a rational graph that has some curve to it, that's not just two straight lines going straight through. So we can list our solutions as x equals 1 and 8. On to the last one, we have number 5 says 3 over x equals 5x minus 1 minus 1/4. And so we take this x, set it not equal to 0, and we get one domain restriction, x is not allowed to be 0. Take the 4x, set it not equal to 0, and we just get x does not equal 0 again. We don't have to rewrite that. And then there's another denominator, but it's just a number. You're not plugging anything in. So if you try and say 4 does not equal 0, you are absolutely correct. And that'll always be true. So there's no domain restriction from just a normal number. Don't overthink it. If there's an x in the bottom, then you take that and make a domain restriction. Just normal numbers are just there as distractors, essentially. So now we go to the solutions, type it into DESMOS, look at the graph. If you type in exactly what you see in the paper, you have 3 over x equals 5x minus 1 over 4x minus 1/4. It looks just like this on DESMOS when you type it in. And you can see that it's not quite a whole number. You could round it, guess. It looks about 3.5. But I'm going to use my trick of putting the right side in parentheses. As you can see, it's already in parentheses. And then change the equal sign to a minus. And there you can see it's changed. It no longer is just a straight line. It's curved like a rational is supposed to be. And I can click on the actual x-intercept or the solution. So my solution would be actually 3.25, not 3.5. This is why sometimes I like to do the change the equal sign to a minus sign, as long as you put parentheses around the entire side. So we can now write our solution. There's only one because it only touches the x-axis once, as you can see. Our solution is x equals 3.25. So that's as complicated as solving rationals will get. Just by looking at DESMOS, you can answer these questions when you look at the x-axis.